This is part 1, Calculus 1 exam questions, either for midterm or final. In this part, I will solve some related rates problems. When we talk about related rates, we talk about how quickly some quantity is changing when you are given how quickly another variable is changing. When we talk about how a quantity changes, we talk about the derivative of that quantity with respect to time. And please do not forget that related rates problems are the applications of implicit differentiation. So we will implicitly differentiate the given equality. So let's look at the first question. A leaky water tank is in the shape of an inverted right circular cone with depth 5 meter and top radius is 2 meter. Let's write down these two information. So the depth is 5 meter and top radius is 2 meter, right? This is 2. Let's continue to read the question. When the water level in the tank is 4 meter deep, it is leaking out at a rate of 1/12 meter cube per minute. So let us say that this radius is r, and let us say that this height is h, denoted by h. So let r and h denote the surface radius and the depth of water in the tank at time t. Let's continue to read the question. How fast is the water level in the tank dropping at that time? So R and H are measured by meters. Thus, the volume of water in the tank at time t is given by this famous formula. V is equal to the volume of the cone pi r square h over 3. And do not forget that V is the volume, r is the radius given here, h is also given here. They are all functions of time. They are all functions of t. They are not variables. They are functions. This is why we will implicitly differentiate this equality. But before to do this, we should decrease the number of functions. We have r and h. So using the geometric identities, using similar triangles, we find a relationship between r and h. What is this relationship? R over h is equal to 2 over 5, right? 2 over 5. And using this equality, we get r is equal to 2h over 5. Okay? So I will use this equality. I will plug this value. So we have v is equal to pi over 3 times, instead of r we have 2h over 5. So since we have r squared, this is square times h. Let's substitute this expression. We finally have 4 pi h cube divided by 75, right? I think now we are ready to differentiate both sides of this equality with respect to time, with respect to t. And please, again, don't forget that h and v are the functions of t, and the others are constants. Differentiating this equality with respect to t, we obtain dv over dt is equal to, let me first write down this constant, 4 pi over 75 times, using the chain rule, 3 times h squared times derivative of h now, since h is the function of t. This is equal to, if you substitute this expression, you will have 4 pi divided by 25 h square dh over dt, right? So what do we know? We know that the volume of the water, the volume of the tank is decreasing, right? Since it is leaking out, the volume of the water is decreasing at a rate of 1 over 12 meter cube per minute. So dV over dt is equal to minus 1 over 12. Using this information in this equality, so minus 1 over 12 is equal to 4 pi over 25. So look at the question again. How fast is the water level in the tank dropping at that time? What is the time here? Time is 4, right? This is actually not time. I mean, this is the height of the water, right? When the water level in the tank is 4 meter, means h is equal to 4 at that time. So h is given, dv over dt is given, h is 4 square times dh over dt. So dh over dt is equal to, if you compute, you will have 25 over this big number, pi. Of course, the result is minus, right? dH over dt is minus something. It means height of the water is decreasing. Second question. A spherical balloon is inflated with helium at a rate of 3 pi meter cube per minute. And we have two questions here. The first one is, how fast is the balloon's radius changing at the instant the radius is 2 meter? The second, how fast is the balloon's surface area changing at the instant the radius is 2 meter? So this is our balloon. The radius is denoted by r. Radius is r. So if you look at the first one, you see that the question is about radius of balloon, right? So one quantity is given and the other one is requested to find. Which one is given? dV over dt is given, right? The volume of the spherical balloon is given. The change in this quantity is given. And the change in r is requested to find. So let me write down the equality of the problem first. Let me write down dV over dt. This is given, right? The volume of the spherical balloon. This is 3 pi meter cube per minute. This is given here. And dr over dt at the time when r is 2 is requested to find. This is the question. Let me write down the volume formula of the spherical balloon. Volume is equal to 4 over 3 pi r cube. Differentiating both sides of this equality with respect to time, and don't forget that v and r are the functions of t. So dv over dt is equal to 4 over 3 pi 3 r square and derivative of r with respect to time. What do we know? We know what is dv over dt. So let me use this information. This is 3 pi dv over dt. I use this equality. This is equal to 4 over 3 times 3 pi times r square. R is given, so this is 4 r square dr over dt. So you have all information from this dr over dt is equal to 3 over 16 meter per minute. This is the final result. Of course, when r is equal to 2. This problem is more complicated. Two people on bikes are separated by 350 meters. So let me write down this information first. So let's say this is person A, stays here. So this is person B, and the distance between these two people are 350 meters. Person A starts riding north at a rate of 5 meters per second, and 7 minutes later person B starts riding south at 3 meters per second. So what do we understand? This person A, starts riding north. So person A is here now. And the other one starts riding south. So the other one is here now, right? Person B. Okay. So the question is, at what rate is the distance separating the two people changing 25 minutes after person A starts riding? So what is the distance separating the two people? This is the distance. Let's say this is Z. Okay. So the change in Z is requested to find. Let me first improve the figure. Let's say this, let's call this distance as X. Let's call this distance as Y. So if you join these two parts, so this is Y, right? And what else? This is 350. This is given in the question. This part, this distance. Okay. So this is 350. Using the Pythagorean theorem, we have x plus y square plus 350 square is equal to z square. So, and we should find z prime, derivative of z with respect to t, and we know x prime and y prime. What are x prime and y prime? They are given in the question. Look at the second sentence of the question. Person A starts riding north at a rate of 5 meters per second. This is x prime. And this is y prime. Okay. So what is x prime? This is 5. Y prime is equal to 7. Sorry, 3. Okay. Of course, meter per second. So let's differentiate this equality. And don't forget that y, x and z are the functions of time, are the functions of t. Derivative of this component is 2x plus y, reduce the power. So the power is 1 times, from the chain rule, derivative of inside, x prime plus y prime. Derivative of this is 0. So this is equal to 2z, and z is the function of t. 2z times z prime. What do we know? We know what is x prime and y prime. But do we know what are x, y, and z? Do we know? Person A has been riding 25 minutes. According to question, person A has been riding 25 minutes, and person B has been riding 25 minus 7. Okay, since he is late, he or she. So x is equal to 5 times 25 times, since it is given by second, we multiply by 60. So the x is this meter. What about y? Let me clear this part. Y is equal to, y also is given. This is 3 times 18. How do we get this 18? I will explain. And this is equal to 3240 meter. How do we get this 18? Since person B is late, right? So he is starting to write 7 minutes after person A, and person A has been writing 25 minutes. Since he is late 7 minutes, you have 18 minutes for person B. And from Pythagorean theorem, since you know what are x and y, you easily have the value of z, right? So using all this information, here x is known, again 7500, y is 3240, and finally using the Pythagorean theorem, you have this meter. They are all meters, and if you use all this information, you'll see that z prime, which is dz over dt, is equal to 8 meter per second. We want to determine d theta over dt, that is theta prime, when y is exactly 200 meters, and we know what is y prime. Let's say this is equal to y, this part, okay, and y prime in this case is equal to minus 15. Why? Since the hot air balloon is starting to come back down, so decreasing, the distance is decreasing. This is why it is minus 15 meter per second. Also, this distance is given in the question. This is 500 meter. This is also given in the question. A person is 5 meters away from the launch point of a hot air balloon. This is the launch point, and this is the observer, the person. So this distance is 500 meters. Since the question is about theta, the quality of the question must be related with theta. So how do we construct an equation related with theta? Let's say tangent theta, using the famous equality of tangent theta. This is y over 500, right? Y over 500. And theta again and y are the functions of time. Why do I say this? Theta is here and y is the distance, theta is the angle, and angle and distance are changing with respect to time. Let's rewrite this equality. Y is equal to 500 tangent theta. And now we are ready to differentiate each side of this equality with respect to time. In this case, y prime over 500 is equal to derivative of tangent is secant square theta times, from the chain rule, derivative of theta, d theta over dt. Okay, rate of the change of the angle is requested to find. So we need to find theta prime, d theta over dt. And we know what is y prime, right? Y prime is minus 15. Let's use this information and write down the equality again. What about secant square theta? Since from the Pythagorean theorem, tangent theta is equal to 200 over 500. How do we say we have 200 over 500? We should look at the question again. At what rate is the angle of elevation changing when the hot air balloon is 200 meters above the ground? So when this is 200, at what rate is the angle of elevation changing? This is the question. This is why this distance is given. So tangent theta is 200 over 500. If you calculate, you see that theta is equal to approximately 0.038. So this is given by radians, okay? Radians. In this case, y prime is minus 15. If you calculate, you see that theta prime, which is d theta over dt, is equal to minus 0.002. What's the meaning of this minus? It means the theta, which is the angle of elevation, is decreasing since the balloon is starting to come back down. This is all.